Graphs and functions. In 2.4, we're going to learn about basic concepts of linear functions, standard form, slope, average rate of change, and some linear models. The linear form for a function is f of x equals ax plus b. The a represents our slope. The b represents our y-intercept. The domain and range for a linear function is going to be negative infinity to infinity, since a and b can take any real value. We want to graph f of x equals negative 2x plus 6, and also give the domain and range of the function. We're going to use the technique of finding the intercepts first, and then we'll plot the points on the graph. So the first thing we need to do is let f of x be equal to 0 and solve for the corresponding y or x value. This is going to give us the x-intercept. So we're going to replace the f of x with 0 and then solve for the x to find the x-intercept. So let's set f of x equal to 0, and then we can add the 2x to both sides and divide by 2 to get x equals 3. Well, since x is equal to 3 and we allowed y or f of x to be equal to 0, we have that the x-intercept is 3, 0. To find the y-intercept, we have to find the value of f of 0. So we're going to plug in a 0 into the function value for the x. So f of 0 equals negative 2 times 0 plus 6. Simplifying this, we get 6. Now, the y-intercept is going to be the point 0, 6. We can also use an additional point, such as 2, 2, because if you plug in the value 2 into the function, you get negative 2 times 2, which is negative 4. Negative 4 plus 6 is 2. So we know that 2, 2 is a point on the graph. So we start by plotting the y-intercept, 0, 6, and plotting 3, 0. 2, 2 is our checkpoint, and it does lie on the same line, so we know we graph the line correctly. If you look at the graph, it goes forever towards the left and forever towards the right. So the domain is going to be from negative infinity to infinity. The range is how far the graph goes down, so it goes down forever, and it goes up forever. So the range is the same, negative infinity to infinity. So in example 2, we want to graph f of x equals negative 3. Now that means for every value of x that I plug in, I always get an output of negative 3. Since the output is always negative 3, we know that the y can never be 0. It can never be 0. Therefore, it must be parallel to the x-axis. So that means we must have a horizontal line, and the y-intercept in this case is 0, negative 3. It goes to the left forever, it goes to the right forever. That's why the domain is negative infinity to infinity. The range is just negative 3 because it does not go below negative 3 and it does not go above negative 3. So that is the range. when I look at the expression x equals -3, that means that x is always going to be equal to -3 no matter what the y value is. That implies that it can never be 0, so there is no y-intercept. This means we must have a vertical line at -3, 0. The domain is just going to be -3. It only goes left to -3, right to -3. It doesn't go anywhere, so the domain is just -3. The range is, it goes down forever, goes up forever, so the range is from -infinity to infinity. Let's graph 4x minus 5y is equal to 0 and give the domain and range. We're going to start by finding the intercepts. To find the y-intercept, we're going to let x be equal to 0. Plug that into the equation. I have 4 times 0 minus 5y is equal to 0. And if we solve for y, we get that y is just equal to 0. So the y-intercept is 0, 0. On the other side, we're going to let y be equal to 0 and solve for x. So I plug in the 0 for the y. 4x minus 5 times 0 equals 0. And we get x is equal to 0. That means the x-intercept is also 0, 0. This graph has just one intercept, the origin, because the x and y intercepts are the same. In order to graph this, we have to find another point. So we're just going to pick randomly any point that we want. Here we're going to select 5 and plug it into x. 4 times 5 gives me 20. 20 minus 5y is equal to 0. And then we can solve for y, which is going to yield 4. And that means we have the point 5, 4 lies on the graph. Now since this is a linear function, the domain and range must be -infinity to infinity. We plot the point 0, 0 and the point 5, 4. We can also pick a third point between them to check our work if we wanted to. So if you plug in -3 into the equation for the x and solve for y, you should get 12 over 5, and plotting that on the graph gives us a line that passes through 3 points, so we know we did it right. Slope is a numerical measure of the steepness and orientation of a straight line. Geometrically, this may be interpreted as the ratio of rise to run. To find the slope of a line, use two distinct points on the line. The change in the horizontal distance, x2 minus x1, is denoted as delta x, and the change in the vertical distance, y2 minus y1, is known as delta y. The slope is calculated by the formula rise divided by run, or delta y over delta x, or the differences of the y's divided by the differences of the x's. We also have a condition that the delta x cannot be 0, or it would be undefined.